Hello. In this video we will show the integration of Nastran within the Optimus workflow. For this purpose we will take the example that we see here below, where we have an oil pan for which we will change the thickness of the flange in red, the stiffeners, the blue one, yellow, and here purple behind this green block, and see their impact on the mass and the mode 1, so the first mode of the system. For this automation, we will use the Nastran interface available in Optimus. So this is here the Nastran icon with a blue border for the input. So we just open it. We have here the interface, which is similar for all the different software that you can use in Optimus. We select here the input file, so the BDF, and automatically Optimus will scan and parse the different parameters which are available. So in our case, we are interested in a P shell and in the thicknesses. So we just select the 4 thicknesses. We can change the name if we want, and we add them as input. So here we will have the 4 different thicknesses, and we will apply the range of interest going from 0.5 to 2 millimeters. We can ungroup. So here we have our 4 different thicknesses available. So this is the modification of the input file. From this input file, we will go in an action box. This action box will actually be the solver of Nastran. So we will launch the Nastran simulation, and we will output FO6 file. So this will be an output from the simulation, in which we will extract the output of interest, so the mass and the mode 1. And you can see that here the interface is similar as the one for the input, but it's reading an output file, so a FO6 file, and parsing this output to display the value coming from the geometry and the first mode. So we simply select them and add, and those will be outputs of our system. So the last step is to go in the action box that we see here in the middle and say to Nastran which input file he has to compute and which is the name of the output file that we want to generate. And here the automation is already complete, so it's extremely fast and extremely straightforward. And from this point, we can already launch a simulation. So we will start with a very simple method called light in hypercube, in which we will do 10 random points. The simulation being pretty fast, it shouldn't be a problem to do it. And during the computation, we see here the console popping up. So you see the computation is are very fast because it's a small model. Sorry. And we will have enough time to do those 10 computation and have a look at the post-processing corresponding to those points. So we are already at 7 out of 10, almost done. As soon as the computation are finished, we will be able to load them. So here we see sequence ended, so the computation are finished. So we load the results and we can start post-processing. So the first post-processing available is called a summary, so in which we have all the 10 experiments that we did and their impact on the different outputs. We can of course sort or filter, so we can see by ascending mode. So we see here that we go from 400 to 600 Hertz, and also for the mass we go from 2.8 ton to 5.6 ton. We can display the point that have been computed. So for example, we can have a global view of all the different design. So this is called correlation matrix. And here we see, for example, the mass is clearly impacted by the T91, which is most obviously the thickness of the flange of the oil pan. So the stiffener are the T1, T2, T3, and they have less impact on the mass. So let's have a look to this plot in detail. So we will look T91 and here the mass, and we see here that we have almost a linear correlation between those two parameters. It's also interesting to have a view of the two outputs together, like here the mode and the mass as a function of the mode, and we see that we have a very low mode and very low mass. But if we want, let's say, to reach something like 490 Hertz at least, you see that you can have very different model giving this same frequency but a very different mass, going from 4.5 thousand to 3.5 thousand. So very big difference in the design. So this demonstrates a little bit and briefly how to use Optimus to integrate Nastran interface and to do a first series of computation and a few post-processing. Thank you for your attention. Bye-bye.